Welcome to 𝒙 Technologies. In this present video, we are going to learn SPI interface with Arduino. We have provided you an SPI based shift register which is actually serial peripheral interface. SPI refers to serial peripheral interface. Normally in I2C, in the previous video, we saw the interfacing with accelerometer, I2C OLED and I2C LCD. These are the I2C devices. Whereas here in SPI, we are going to use different bus configuration. In SPI, we have three or more lines. Generally in I2C we have two lines only, SDA and SCL. So the clock is supplied by the master and the data will be either transferred from master to slave or slave to master only on the SDA line. So that is I2C. But in SPI there are two dedicated lines, master in slave out and master out slave in, MOSI and MISO. So there are separate lines for slaves to send the data. There are separate lines for slaves to receive data. That is the basic difference between SPI and I2C. In SPI, you can have the same clock line, but with the two different data lines. One from processor to slave, another from slave to processor. And there is one more pin, which is what you call as slave select. So that particular pin selects a particular slave, and there is no address in the case of SPI. Whereas in I2C there are fixed address for slaves. In SPI there is no address. It is only the master which addresses a particular slave by sending a particular pin either high or low, and it starts communication with that. There is no address concept here. So we are going to interface this with the help of the code, and we are going to create LED patterns. Either you can generate the LED number. Actually it's 8-bit na. So this 8-bit you can have 0 to 255 numbers. This is LSB and this is MSB. So from LSB to MSB you can print 0 to 255. All LEDs glowing is 255, nothing glowing is 0. So you can just send any desired number, or you can create animations like scrolling effects, the moving, etc. using this particular register. Now let us see the code provided to you. So here the code is SPI LED numbers printing. This is one particular code. So if you open the sketch, basically what it does is it is going to print the numbers 1 to 255 and then back to 0 on this particular one with a little bit delay. So that's what we are going to see. So in the sketch, basically we are using SPI library. It is a built-in library. You don't have to install anything. It comes with Arduino, and we are using pin 13 as output. This is the Arduino's serial clock. This is the SCL plane. And similarly pin 11, it is also Arduino's output, which is the master out slave in pin of Arduino. And remember, these pins are fixed. You cannot execute this on any other pin. These are the SPI pins of Arduino. You cannot change the pins. If you want to use ultrasonic sensor, you may use a different bus. But if you want to use either SPI or I2C devices, their buses are already fixed on any device. There is no choice to change the buses. Similarly, pin 10 is output. This is Arduino slave select. So this is slave select, and remember there is no MISO. That is, this register is only slave. It is not going to return anything. Whatever the master says, it just executes that particular pin, and there is nothing to be transferred to the master. That's why we are not using the other pin, which is pin 12, which is MISO. So MISO is not used here because there is no communication happening from the shift register to the Arduino. Only Arduino is ordering, shift register is executing. There is no return response from that. And pin 10 is for slave select. As I said, slave, if you want to select, you have to just a pin high, and then for a short duration you keep it there, and then low. So the high to low, low to high trigger will select the slave. And this SPI begin enables the serial peripheral interface, just like DHT.begin, serial.begin, we are enabling the SPI communication. And as usual, serial port we are enabling. See this, update shift register 0. So this is a created function. It's not built-in function. We have created a function called update shift register with 0. This is to make sure that if you upload the code, 0 is written to the shift register. That is, none of the LEDs must be glowing after you upload the code initially. So at the start of the program, it just glows. It doesn't glow any LEDs. And then serial.set timeout, only to make sure that the serial port doesn't get logged for not more than 10 millisecond. It is just keeping the set timeout for serial port. And then these are comments we haven't used. So first thing, here we are not taking any input. Basically it is demonstrating that the reason for commenting these things. Actually, if you take this, it will prompt you to give some number. Let us say if I give 10, it will just glow the 10 on this LEDs, binary 10. So like that it was written. That program is also there. But in this current program, what we have done is, for int I equal to 0 to I less than 255, update shift register with that value and 100 delay. Means for every 1/10 of the second, an LED will be glowing. Very simple code. Just if you upload it by selecting the same port and COM, processor, etc., you will see on this screen in a moment. Now the code is getting uploaded. Just I am trying to show all these things together. Now uploading done. See, the LEDs will start glowing. Please observe, the LEDs are actually moving. So it is counting binary. So once after it reaches 255, it then goes back to 0. So it is basically counting the numbers from 0 to 255. Almost 255 we are approaching. All the LEDs are getting on. Yes, now it's off. So once again it's starting from 0. So in this way you can actually count the numbers in binary. This is one program. There is another program given in that, SPI LED animation. So in this one you can actually create an animation effect with this. So instead of printing numbers 0 to 255, you can actually make a scrolling effect, something like Knight Rider, the animation effects with this. So same code, but here what we have done is just we have shifted. So we have given functions like a spin 1, delay 1 second, and then blink, Knight Rider, delay 1 second, alternate 1 second, chasing 1 second, opposite ends 1 second, another opposite ends 1, another. So these are the functions. What we have done is we have taken update shift register. You see, earlier we have taken one value, either increasing or decreasing. Now what we have done is we have left shifted. You can see 1 left shift I. So we have just changed the value of I. If at all I starts with 1, next one will be 2, next one will be 4, binary 4, and then next one will be binary 8, like that. It is going to shift it towards the left hand side. And similarly the spin, it has taken I, it has taken I, and it is incrementing the I, and it is shifting the same register towards left when it is less than 8. I is less than 8 means shifting left, and when it is greater than 8, it is shifting 1 bit, 16 minus I. So it is just trying to create an LED moving towards left and then going back. So these are basic animation functions which you can easily understand. Let us upload the code and see how the things will go on. Now the code is uploading. Still the LEDs are following the old code. Now the code is uploading. Now we will see the animation. See, spinning, scrolling, Knight Rider effect. So these are the animation effects with LED which you can perform using SPI. Thank you.